Okay, in this problem, I'm going to show you how to solve for the percent yield. This problem can be found on your worksheet from the Friday before break, or maybe it was the Thursday before that. Anyways, it's called 11.4% yield, and this is the second problem on that page. Okay, so in a percent yield problem, you're always going to be given two numbers in the problem. And in this particular problem, it's the 84.8 grams of iron 3 oxide and the 54.3 grams of iron. Now, out of those two numbers, one of them is going to be our actual yield. And we have to kind of look at the equation and look at the wording to decide which one is our actual yield. In this problem, our iron, so our 54.3 grams of iron, is our actual yield because it is on the product side of the equation. So we're going to rewrite our 54.3 grams of iron here. Sorry, my handwriting's a little messy. I forgot my stylus, so we'll make do. All right, going back to the problem, we've got our we've got an equation and it's not balanced. Hopefully when you look at the equation, you notice the irons aren't balanced. So we're going to put a 2 here. Also, the oxygens aren't balanced. So we're going to put a 3 here and a 3 here. All right, so those are our first two things. We found our actual yield and we balanced the equation. Next order of business is going to be determining our theoretical yield. So the way we're going to get that, this is the number you should get. Theoretically, you should get when you're doing this problem. So we're going to take this other number we haven't used yet, our 84.8 grams of iron 3 oxide, and we're going to convert that to grams of iron. The reason we're going to do this is our actual yield was in grams of iron. That was its unit. So therefore, we need to get our theoretical yield in that same unit so that we can compare them. Okay, so we've got our 84.8 grams of iron 3 oxide. So then we have to go moles of iron 3 oxide to moles of iron, and then grams of iron is in your last box. Diagonal from grams is grams. Diagonal from moles is moles. Remember, they always have to be the same when they're diagonal, so they cancel out. And then diagonal from moles is moles again. When you're setting up a grams to grams problem, this moles will always have a 1 and this moles will always have a 1 because they're with grams, and so that's just the conversion factor. 1 mole equals a certain amount of grams. The way you get the grams is from the periodic table. So iron is its molar mass is 55.85. So we're going to put that there. And then when you find the molar mass of iron 3 oxide, you end up finding out it's 159.67. Oh, sorry, my handwriting's really bad there, but that was 159.67. The last thing to fill in is our mole ratio. We get that from the balanced equation. So we look at the balanced equation, and there's a 2 in front of our iron, so that goes here. And then we look at our balanced equation, and there's nothing in front of our iron 3 oxide, so we put a 1 here. Now mathematically, you're going to do 84.8 times 2 times 55.85. Hit equals, then divide by 159.67 grams. And that will give us our final answer for our theoretical yield, which is 59.32. And that's grams of iron. So this is our theoretical yield, 59.32. What your theoretical yield is it's what you technically should get when you're doing this experiment or this reaction. That's how much iron you should produce. And then the actual yield is how much a person actually got from doing the lab. So the last thing we're going to do is the percent yield. The percent yield is the actual yield divided by the theoretical yield times 100. And then it'll give you a percent. The grams will cancel out. So we're going to take our 54.3 grams of iron on top, and we're going to divide it by our 59.32 grams of iron on the bottom, and multiply that by 100. Okay, put that into your calculator, and hopefully you get what I got, which is 91.54. And this is percent. That's a pretty good percent yield. You usually want to be in the 90s, close to as 100 as possible. And that's our percent yield, so we are all done.